All right, everyone, welcome back. This is the final video now in Lesson 9 for Module 3 and also the final lesson as well. We're examining complex numbers. So I decided to end the video, a previous video, early so that way I could spend a little more time talking about this and rather than having it all in one long video. So we are asked to verify that these two complex numbers are solutions to this equation. Now, how do we verify solutions to an equation? What do? We take these numbers and we plug them in for the x's here and see if we end up with making the equation true. That is, does it equal 0 in this case. So let's do that. So we'll plug this one in first. So we're going to check, or we'll verify x equals -1 plus 2i. Okay, so it'll be -1 plus 2i squared plus 2 times -1 plus 2i plus 5. Equals 0. Okay, so let's square it out. Now when you square something, you multiply it by itself, right? So this is really going to be then -1 plus 2i, -1 plus 2i. I'll go ahead and distribute the 2 here as well, so it'll be plus -2 plus 4i plus 5 equals 0. And then we'll distribute -1 times -1, -1 times 2i. 2i times -1, 2i times 2i. So 1 minus 2i, or no, sorry, plus 2i, no, minus 2i, because it's -1 times 2i there. And then 2i times -1, which I said was -2i, and then 2i times 2i, which is 4i squared. Then minus 2, then plus 4i, then plus 5 equals 0. Okay, and now let's simplify. So let's see here. We can combine like terms. So the 1 combines with the minus 2 and the plus 5 to make 3. No, sorry, 2. Nope, 3. 1 minus 2 is -1, plus 5. Oh, it's 4. Goodness gracious, 4. Okay, and then we have a -2i, a -2i, and a positive 4i, so those all cancel. And then we have this plus 4i squared. Remember what we said earlier, what does I squared simplify to be? I squared is just -1. So this becomes, I'm going to run out of space here, 4 plus 4 times -1 equals 0, okay, which in fact gives us 4 plus -4, which is 0. Check. So that solution works. Now let's try the -1 plus 2i, or sorry, -1 minus 2i solution. Okay, so again, we'll plug in this in for x here. So we'll verify x equals -1 minus 2i. Plus 2 times -1 minus 2i plus 5 equals 0. So again, we'll multiply this out. And we'll distribute there. So we'll get -2 minus 4i, and then plus the 5. Okay, multiply it out here. So -1 times -1, positive 1. -1 times -2, positive 2. -2 times -1, positive 2. -2 times -2, positive 4i squared. Bring down the -2, the minus 4i, and the plus 5. Okay, and now again, let's combine like terms. So we have the 1, minus 2 is -1, plus 5 is 4. And then the 2i and the 2i and the minus 4i are going to all cancel again, and we're left with 4i squared equals 0. It's the exact same thing we left with over there, that 4 plus 4i squared. And so we know that's going to be just 4 plus 4 times -1, which is just 4 plus -4, which is 0. So check, it works. Now, that's one way you could verify here, but the second way you could verify, okay, which again, verifying was just involving plugging in both of these into the equation. Another way you can verify this is to find the actual solutions of this and see that they match these two complex numbers here. How do we do that? Well, how would you solve this quadratic equation? We have lots of different strategies, right? Would factoring work? No, factoring is not going to work. We can't think of two numbers that multiply to make 5, but add to make 2. Could we use square roots? Well, not right away, no, because you have both the x squared and the x here. Even if you isolate the x squared, you'd have an x over on this side, and when you square root both sides, you'd have x's in the answer. We could complete the square, but that's, you know, maybe not everyone's favorite thing to do. So we're going to go ahead and do this with quadratic formula, okay, because that's our final option here, which also might not be your favorite thing to do. So it's going to be our a is 1, our b is 2, and our c is 5. So x equals negative b plus or minus the square root of b squared minus 4 times a times c all over 2 times a. And then we just simplify here. So negative 2 plus or minus the square root, so that's going to be 4 minus 20 over 2, which gives me negative 2 plus or minus, so that's going to be negative root negative 16. So that's square root of negative 16. Let's do a little sidebar over here. That's equal to root negative 1 times root 16. What's square root of negative 1? Remember we said that was I. So we're going to say this is I. And what's the square root of 16? Well, it's 4. So this just becomes 4i. Okay? So we'll have negative 2 plus or minus 4i all over 2. All right? And then we'll divide everything by 2, right? So this is negative 2 over 2 plus or minus 4i over 2, which gives us negative 1 plus 2i, and, or plus or minus, sorry, 2i. And hey, look, those answers, negative 1 plus or minus 2i, negative 1 plus 2i, negative 1 minus 2i. So that's another way you could verify here, by actually finding the solutions and just seeing if they match up. Okay? So in summary here, multiplying by I, that's an interesting thing to say. Multiplying by I rotates every complex number in the complex plane by 90 degrees about the origin. We didn't really talk too much about that at all, so don't worry about that. Every complex number is in the form a plus bi, where a is the real part and b is the imaginary part of the number. Okay, real numbers are complex numbers, like pi, 3, 10, those are complex. They just don't have this imaginary part. So like the real number a can be written as the complex number a plus 0i. Adding two complex numbers is just like combining like terms in a polynomial expression, and then multiplying is like multiplying two binomials, except don't forget that I squared is equal to negative 1 to help you simplify. Okay, so thanks guys, and we'll see you in module 4.